Mhm.
Recording in progress.
Mm.
We are magicians. Throughout history, we have been doing things that people never thought possible. We make buildings rise and stand proud. We make cars move so people can get from one place to another. And we've made it possible for people to move again when they thought they never could. When the world gets dark, we light things up. And help to make things pure and clean. We help power the world. Give it the fuel it needs. And make sure that we are able to harness and sustain the energy that nature provides. We do things that help make the world a better place. But we wouldn't be able to do what we do if it wasn't for somebody. Somebody who lets us fly, but makes sure we fly to a certain standard. Somebody who keeps an eye on us. And sees to it that we are made of the right stuff. Somebody who keeps us doing things the safe and sustainable way, no matter what. Somebody who makes sure that we are professional in our dealings. Somebody who encourages us to keep learning so we can create more magic. And somebody who tests us so that what we do is always done right. We are an engineering team. We strive to make the world a better and safer place. We are able to do it thanks to the Board of Engineers, Malaysia.
Assalamualaikum warahmatullahi wabarakatuh and very good morning. Welcome to the webinar of the Engineers and Society lecture series. In support of the Board Engineers Malaysia BM Strategic Plan, the Engineering Accreditation Council EAC and the Engineering Technology Accreditation Council ETAC formed the working group on National Undergraduate Engineering Talent (NET). This working group focuses on the developments of future-ready undergraduate engineers through structured programs that promote leadership, innovation, ethics, and professional engagement. The group will spearhead structured initiatives to develop leadership competencies, enhance professional exposure, and embed the core values of the engineering profession. Among the initiatives under Nuet are Industry Talk under Engineers in Society, Industry Advisory Panel Registration Mechanism, and Innovation Competition involving funding projects and integrated design projects. Ladies and gentlemen, let us start our webinar today. On each of the slides, there is a QR code located at the top right. If you have any question, you may scan the code and submit your question there. Due to the time constraint, we may not be able to answer all questions live today, but we will respond to them in due course and upload the answers on the Google site. We'll start with the Module 1, Engineering Career, will be presented today by Yang Bahagia Dato Engineer Dr. Abdul Rahim Hashim. Dato Engineer Dr. Abdul Rahim Hashim is a distinguished Malaysian engineer and senior leader with over 40 years of experience across the global energy sector, higher education, and national science and technology policy. He is a fellow of the Academy of Science Malaysia and honorary president of the International Gas Union. He previously served as Vice Chancellor of the University of Malaya and Vice Chancellor or CEO of University of Technology Petronas, following a long and accomplished career in Petronas, where he held key vice presidential roles in gas business, research and technology, and human resource management. He also led major refining and LNG ventures as CEO or Managing Director. Dato Abdul Rahim has served on numerous corporate and national boards, including Petronas Chemical Group, Petronas Gas, Gas Malaysia, Serim, the Energy Commission, and Dilian Berhad. He remains active as an independent director of MITE and senior member of the board of Engineers Malaysia. A sought-after speaker, he regularly shares insights on energy transition, sustainability, innovation, digital transformation, and engineering leadership at global and national forums. Please welcome Dato Rahim.
Thank you, Engineer Zairul. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera and a very good morning, everyone. It is a privilege for me this morning to speak to the next generation of engineers. And today I'd like to help you to see the bigger picture, not just your degree, but the opportunities, the pathways, and responsibilities that come with this profession. Now, engineering is a foundation that will give you the ability to solve problems, introduce new ideas, and make a lasting contribution to society. Next slide, please. Now, you are actually a part of the Malaysia's national engineering talent pipeline, yeah? And the country requires a very, very strong, competent, and ethical engineers to support not just the digital economy, but also the transition, energy transition, advanced manufacturing, sustainability, and also national innovation. Yeah? And you're not just students per se, you are actually the future contributors to Malaysia's global competitiveness. Yeah? Now, the engineering world has really changed. Yeah? Careers today are very, very broad, more flexible, and more interdisciplinary. Now, my aim today is to give you a clearer understanding of how your engineering career can evolve, what pathways lies ahead, and how you can prepare yourself effectively. Next. Now, as far as engineering disciplines are concerned, now this particular visual illustrates the so-called diversity of engineering environments. Yeah? In terms of, you have the various record disciplines. Now, mechanical engineers may actually focus on energy, manufacturing, and aerospace. The chemical engineers can contribute to process industries, materials, and biotechnology. Electrical engineers in power systems, yeah, in semiconductors and electronics, especially so now. And of course, the civil engineers help to build and maintain infrastructures, yeah? And this question is in terms of your discipline will give you the tools, but your curiosity, yeah, and adaptability will determine where you eventually will go. Yeah. Next slide, please. Now, the pathways here as one of the areas that you can actually go to. The engineering is in fact no longer a single straight path. You can actually go into the public sector, which is the government agencies, the so-called government departments, and so on and so forth. And also you can go into the so-called the private sector. Yeah. Now this ecosystem is that you can go into the academia and also into R&D at the same time. So the question is that where does your passion lies as far as your career is concerned, or your chosen career is concerned, right? Next slide, please. Now, I think what the other area, perhaps I think more of a concern, is that the Malaysia's engineering-based startup ecosystem is actually growing. Now, engineers today are leading innovations in drones, yeah, in robotics, and AI-based platform, as well as medical technology and agriculture technology and smart city solution. So you actually no longer need to join companies per se. I think what you can do is then you can create your own as well. Yeah, that's the message here. Now, next slide, please. I think what's important here, as far as internship is concerned, is not just a mere requirements of your academic life, but they are actually the starting block of your engineering journey. Yeah, choose your placements right that expose you to real engineering challenges. Volunteer for some more difficult assignments, and learn from the senior engineers. Now, these experiences will definitely shape where the industry, your passion lies, and also in terms of determining where your first jobs are. So make sure that you understand as far as this landscape is concerned. Next slide, please. Now, the engineering career ladder typically progresses a graduate engineer from after you have left university to an engineer, and then perhaps move on to senior engineer, principal engineer, and subsequently to managerial and more senior leaderships and technical authority roles. So the advancement is that your progress really depends in terms of your competence, your consistency, and the willingness to take on added responsibility. And of course, I think more important is that your appetite for learning. Yeah, I think that's very, very, very important. Next slide, please. Now, between 3 to 7 years normally of your career, you start to build your foundation. Yeah, understand the role that you are playing, and then subsequently you begin to manage systems, manage a bigger organization. I mean, solving problems independently, coordinating projects, and mentoring younger engineers. So that's your sort of the career progression. Now, this is perhaps I think the important area is that where you consolidate, yeah, your career in this particular part of your growth. And this is where your reputation as an engineer really being established. Yeah? And as you move forward, then you go into the leadership role. Yeah. Next slide, please. Now, I cannot overemphasize as far as this area is concerned. Now, you can actually be going into various areas. Yeah? You can be a technical expert. This is where your depth, your technical authority can be established. Or you can actually go into consulting, yeah, providing expert advice to improve project outcomes and even drive innovation for that matter, yeah. But also some people will not like to become a technical expert, but will go into sort of the senior management role, yeah, becoming a chief technology officer and subsequently become CEOs of the organization. So you have actually multiple roles, but these are the so-called advanced role in your career. Next slide, please. Now, as far as lifelong learning is concerned, this is something which you will definitely have to be on guard all the time. Yeah, in terms of your career, it's not just the technical aspects as well, but I think it's more important is the consideration as far as for sustainability is concerned, and also your contribution to society as a whole. Maybe the role that you play, you can actually contribute as far as CSR is concerned. This is corporate social responsibility initiative, volunteering some initiative in the society in your area that you are working, and of course synergizing the engineering capability and the so-called social responsibility at the same time. Yeah. Okay, move on. I cannot overemphasize as far as lifelong learning is concerned, because this is an area where technology moves quite fast. Yeah, you actually they're moving much perhaps faster than we can think of, and you need somehow or other to make sure they are at the level where the technologies are. I think some of this information includes automation, digitalization. Of course, everybody talks about AI now, so you definitely have to somehow or other get in touch with all this, and how can it actually help you in your own work areas, but at the same time is that how can it actually help you as far as complementing the skills or the expertise that you have. Yeah? So areas like I mentioned about AI, but digital twins, automation, simulation tools, data analytics, and so on and so forth. These are making sure that you stay relevant, and you must somehow or other continuously upskill and adapt to these so-called technology advancements. Yeah? Next slide, please. As far as the Engineers Act is concerned, it is, I think, part and parcel of our role here is to make sure that if you are a professional engineer, now continuing professional development or CPD is now mandatory. Yeah? This is basically to ensure that engineers maintain their competence, yeah, uphold the ethical standards all the time, and also remain aligned with global industry expectations. Yeah. And it covers not only the engineers, but also covers also the inspector of works and the technologists at the same time. Okay. Next, please. Now, this is again another emphasis on CPD. What we require is that the professional engineer must accumulate CPD hours through structured learnings. And this includes covers industry training, professional courses, technical seminars, certifications, and academic activities. So these are all aligned with global professional engineering standards. So the requirements is not just with us, but also globally at the same time. Okay, next, please. I think what is important here is knowing that the Malaysian qualification under the Engineering Accreditation Council, EAC, that and also ETAC, we are actually part and parcel of the Washington Accords. This is for engineers. The Sydney Accord is for technicians. Sorry, the Dublin Accord is for actually for technicians, and Sydney is for technologists. So your degree is actually valid in about 25 countries. So the certification is that. The question here is that you can work anywhere internationally in countries, even such as UK, US, Australia, Korea, Japan, even Canada for that matter, provided you build your fundamentals and your relevant competencies very, very strong. Yeah. Next slide, please. Now, you are not expected to know everything today, but I think what's important is for you should begin reflecting on your interests. What actually drives you? What industries that excites you? And what kind of work that gives you a sense of purpose. Yeah. Now, all this so-called your own answers, yeah, will actually guide the pathway that you choose. So all this is important to sort of step back and say, where should I go? What exactly do I want to do? Well, what exactly that my passion is in this particular areas. So this is knowing your direction is very, very important. Okay, next slide, please. Now, network is so important. At the end of the day, it's not just about what qualification you have, what expertise you have, but somehow rather the so-called people that you know, especially your peers, people in various industries, because you are working as part and parcel of a team. So, and also industries are now interconnected. So it's very, very important to cultivate the connections. And you can do this through joining professional bodies or events, or even, I think more important is finding mentors. Up front, when you start your career, get some senior engineers to provide you with advice, perhaps, or also a second voice or a third voice to give you some perhaps better direction in terms of your career progression. And remember, it's all about people. Yeah, it's not just looking at the social media itself, but real connection is very, very important. Next slide, please. And I like just for you to remember three things. I think one is beginning with an end in mind, which I talked earlier in terms of what are your passion, what your strengths are, yeah, and where do you need to sort of get into as far as your maybe whether it's industry, whether you want to become a technical expert, or whether you want to go into management per se. And all the time, make sure that you embrace every opportunity that you get, yeah, for you to gain the necessary experience. Make sure that your toolkit is fully developed. You have all this so that any opportunity that comes along, you are able to address those appropriately and move on with your career. Yeah, but to do that, you must somehow rather invest in yourself. Yeah, which means that make sure that you cultivate your skills. Yeah, you attend programs, make sure that you are abreast with technologies, and also making sure that your network is solid, so that you can always refer to some of these people whenever that's required. So you are just not building a career per se. You are actually building a life. And I say here, make sure that that life counts. Yeah. So I think the last slide. So in closing, next slide, please. I just like to sort of, apart from that three just now, before I end, there are some messages that I would like to make sure that you take this along, is that apart from this, you build your foundations. Make sure you really build them, because engineering is not about memorizing formulas. It's about thinking critically, thinking clearly, solving problems, and applying principle. So if your fundamentals are strong, you can work in any industry anywhere in the world. And then the other one is that invest in yourself is to stay curious, because technology will not wait for you. Yeah, AI, digitalization, energy transition, and so on and so forth. So the world is moving very, very fast. And engineers who succeed are those who learn continuously. So be the kind of engineer who is always upgrading, always exploring, and always improving. And lastly is that whatever you do, choose impact. Yeah? It's not about titles, not about glamour. Engineering is ultimately about improving lives, building systems, and shaping the nation. So if you choose roles that you can make real impact, your career will be very, very meaningful, fulfilling, and also at the same time respected. Yeah. So if you do all these three things, I assure you, yeah, not only you will find success, you will become the kind of engineer Malaysia needs, and the kind of the world will welcome. Thank you.
Thank you, Dr. Rahim, for the insightful and a very inspiring presentation. We have a first question from the participant. The first one, what inspired you to pursue a career in engineering?
Oh, when I actually was a student, or well, I was quite young, I was passionate with somehow rather with mechanical things, yeah, things that I will repair bicycles. I will do a lot of things coming out what bells. At that point in time, we had the so-called industrial arts class where you go into a workshop and you tinker around with all sorts of things. You have projects to do and so on and so forth. So that sort of create an initial interest in areas where perhaps I'm perhaps good with my hands and able to sort of figure out how thing works and perhaps wanting to go further into that particular areas.
Thank you, Dato. So next question is, what should students do if they're still unsure which engineering field suit them?
This is where I think you have to rely on your strengths first. For example, if you want to go into electrical engineering, I mean electrical electronics, you have to be very, very strong in your maths, for example, as an example. Not does it mean that other engineering disciplines are not maths related, but particularly, because you have got all sorts of theorems, all sorts of, so your pure maths still has to be very, very strong. You have to have an interest in that. You have to have interest in science, for example. I'm not good in chemistry, for example. So I do not want to go into chemical engineering, for example. Yeah. So the question is that how do you play to your strengths and what are you interested in, what you're passionate for you to determine which engineering disciplines that you ought to go into. Yeah. But now there is also a program at University of Technology Petronas, which is called Integrated Engineering, which covers both mechanical as well as some other minor disciplines at the same time. So if you are not sure, you go into integrated engineering, as an example.
All right, thank you, Dato. Next question, how important is practical experience compared to academic results?
The practical experience here is it provides you with a view in terms of how the real world works, right? If you get an internship perhaps during your third year or even your earlier part of your final year, is that it gives you a view in terms of how things work, and it gives you also a chance to help develop your other competencies. Yeah, your soft skills, for example, how you interact with people. Because as an engineer, you work in a team. Yeah, you work in a team. You also be able to do presentation, yeah, communicate with others as well, and at the same time, you work with other disciplines. So your interpersonal relationships too is very, very important. So internship helps develop that. If it's long enough, you can have a specific project to do, which is something substantive you can be proud of. So it complements the academic side of things. Yeah, the academic side of it is all about theory, but sometimes you go into the industry and so on and so forth. You may say, for example, as a chemical engineer, you may want to say that what is a check valve is? What is what do you call a distillation column look like internally, for example? So you have the chance in the internship program to do that. Then it gives you a sort of a better understanding of what theory is all about, what you learn in class relating to the actual world.
All right, thank you, Dato. Next question, what skills should engineering students prioritize to stay competitive in the future job market?
Of course, I mentioned everyone will come up with a degree. Yeah. So what's the difference between one to the next person? Obviously, I mentioned about soft skills are very, very important. But also, what you can actually make a difference is that if you, during your own time, come up with or attend specific programs, which is perhaps in line with engineering program, but this is on your own initiative. For example, you can take a program on AI, for example, specific on AI. Take a program specific on, if you are electrical electronics engineer, on interconnectivity, for example, in terms of, there are various programs. You can go into Coursera, for example. There are a lot of free programs there. That one will sort of enhance you, and also not forgetting, you have somehow or other to get into an AI program. People will say that AI will not replace people, but people will be replaced if they do not have AI competencies. So I would suggest that you must somehow or other skill up yourself to make sure that not just job ready, but be able to also address, I guess, assignments as you come on board the workplace.
All right. How important is networking for career growth, and how can students start building their network early?
I think your networking, as I mentioned, is crucial, because at the end of the day, you get things done through other people, not just within your own outfit, but also other industries and other peers. Perhaps not, it could be your competitors and so on, but they're important. Now you can start that off if you are involved in, say, societies, for example. IEM has got a chapter in most. Get involved in that, because they have got various programs in there, and get involved in competitions, because you are linking yourself not just within your own discipline, but interdiscipline, and also intra universities at the same time. So that's how you start, and you get sort of connected with these people even after you have completed your program. So you build that network all the time. And when you start working, make sure you join professional organizations. That's where you do that. And I think one area perhaps I can suggest is that during your student days, you volunteer to do various assignments. And that's where you get connected with people from not just disciplines, but other programs at the same time. So you don't want just to sort of mix around with engineers per se, or engineering students per se, but also the so-called other faculties at the same time. So volunteering is actually very, very important. You get, again, sort of interconnected with the society, because at the end of the day, you're trying to solve societal issues or societal problems. So I think that's important.
Thank you, Datuk. Next question, Datuk, from student. When you started your career in engineering, what challenges do most young engineers face in their early years?
Well, early years is always you are given an assignment. For example, if you, for example, a chemical engineer, I come from the oil and gas industry. I work in refineries, for example. As a chemical engineer, normally you are giving specific assignments to do. For example, this is quite technical. The preheat train of a refinery, for example. Those assignments are very specific. It's task oriented. So I think what you need to do is to make sure that you do that particular assignment well. How do you go about doing it? Of course, as I mentioned, you need to have somebody, a mentor, perhaps a senior engineer, who will brief you in terms of how to go about doing it. But I think it's more important also because you are working in an environment where safety is very, very crucial. Follow the safety rules properly and so on and so forth. But at the same time, interconnect with perhaps the operators, the technicians of the plant, for example. Sometimes people forget that, and make yourself humble, because you are just about to start your career, about to start your assignments and so forth. That doesn't mean that you have a degree, you are above them. Not quite. They have got experiences, some of them 20, 30 years experience. So they are very, very experienced. So make sure that you get connected with them, because they can assist you in your job. And you will not know a lot of things. but keep learning. I think this is very important, is keep learning. When there is a chance, for example, that provides you as a chemical engineer, for example, or even electrical, mechanical, there is a shutdown of the plant and so on and so forth. And when they open the so-called vessel, get the opportunity to get in, understand the internals of those things and so on and so forth. So your opportunities are a lot. Just open your eyes and make sure that you understand the upstream, your downstream of your work, so that's how it impact your particular assignment, and what the impact is in terms of once you've done it well, how can it improve the subsequent downstream part of your assignment. So holistically, you must understand the assignment that is given to you, not just doing it for the sake of doing it, but what does it impact and how you're going about doing it, and also at the same time the lessons learned subsequently. What do I do well, what I don't do well as far as those assignments are concerned.
All right, thank you. Last question. What advice would you give to students about shaping their long-term career?
Sometimes you can have that sort of vision, because some people say, I do not want to become a manager, or I'm not so good in terms of looking after a big group of people. I just want to focus in my technical mastery. Yeah, you can actually do that. So it determines again upfront, what do you think is your passion? What do you think is your strength? And where is your interest? Right? Let's say I want to become a technical expert as an engineer in this particular area. Right? You can actually determine up there, because subsequently you can then, after you finish your sort of 4 or 5 years of working, you can do your masters, and then perhaps if you really want to go into depth, you can do your doctoral thesis and get a PhD, and move along that lines. Yeah, but some people says, that's not my cup of tea. I would just like to sort of become a project manager who manages a group of people in terms of coming up with projects, completion, and so forth. So you can go into the management area and subsequently move on to head big organizations, and perhaps set up your own consulting firm in that manner. See? So I think you need to somehow or other talk to people. Yeah, talk to people in terms of, and they will ask you questions in terms of, do you find this interesting? Do you find that interesting? What exactly? Just to find a niche in terms of where your interests are. Yeah, because if you don't know your interests, then as the saying goes, if you don't know your end game, then any road will lead to somewhere that perhaps you are not planned for.
Thank you, Dr. Rahim. Any last word before we move on to the next module?
Yeah, as I mentioned earlier, I think what's important at the moment is to make sure that your foundation is solid. Yeah, your foundation is solid, and to make sure that you continuously learn. Yeah, and make an impact. At the end of the day, it's all about making an impact, and perhaps as you move on your career, you leave legacies behind as well.
Right. Thank you once again, Yang Bahagia Datuk, for your valuable sharing and for addressing the question. We will now proceed to our next module, Module 2, Practice of Engineering in Malaysia. This will be represented by Yang Bahagia Datuk Profesor Engineer Dr. Muhammad Rafiq Abdul Kadir. Yang Bahagia Datuk Profesor Engineer Dr. Muhammad Rafiq Abdul Kadir is a highly respected engineering leader, academic and researcher. He previously served as a founding dean of the Faculty of Engineering at UC Technology Malaysia and currently serves as council member of the Engineering Action Council EAC. A distinguished scholar in biomedical engineering, has led numerous impactful research projects, secured major competitive grants, and hold multiple patents. His contribution extend across academic leadership, innovation, and advancement of engineering education in Malaysia. He is widely regarded as one of the nation's most influential figures in shaping the future of the engineering profession. Please welcome Prof. Dr. Rafiq.
Bismillahirrahmanirrahim. Wassalatu wassalamu ala rasulillah Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to all of you, future engineers. First of all, I would like to say thank you so much to the Board of Engineers for giving me the opportunity to talk to our future engineers, and thank you to all of you for joining my talk. Okay, let's continue. Let's continue from Dato' Rahim's presentation. So my presentation, there are 6 items there related to engineering practice, and then registration of Engineers Act, regulatory structure overview, the registration of engineers and their processes, as well as our responsibilities. Okay, next slide. Now, let's start with this very important sentence. And that important sentence is: engineering practice involves applying scientific principles to design, number 1, develop, number 2, and innovate, number 3, solutions that meet societal needs and enhance quality of life. If you join this webinar, at the very beginning of the webinar, there was a montage, and there was a quote from Elon Musk, and the quote was something about engineering being the closest thing to magic. So engineers are magician. Engineers are magician. So that is according to Elon Musk, and I want to believe that is true. The closest thing to a magic are the things that engineers do. And I just want to add my own word regarding engineering, is that we are the professions, we are the people who develop countries. So countries that are underdeveloped, engineers will convert those underdeveloped countries into developing countries, and then from developing countries into developed countries. So if Malaysia, for example, if we consider Malaysia as a developing countries, now the only way for us to move forward into a developed country, we need engineers. And then if we consider ourselves, our country, as an already developed country, then we still need engineers, more engineers to go far and beyond. So congratulations to all of you for choosing this profession, engineering profession. So, and the Registration of Engineers Act 1967 have all the regulations that are needed by engineers. There are a few sections there, in particular, Section 7 and Section 10. Section 7 and Section 10 in particular, who defines legally allowed, who are the person legally allowed to practice engineering, and who are the one who can use the title engineer. Yeah, that is in Section 7. And Section 10 will specify the criteria and process for graduate engineer registration with BEM. And 10.1b, 10.2, and 10d establishes the need to move from a graduate engineer to a professional engineer, and then from a professional engineer to a professional engineer with practicing certificate. And there is also a section on enforcement and penalties. Next slide. This is an overview of the regulatory structure. So you can see that the Board of Engineers on the left oversees licensing of engineers. And then on the right, these are some of the professional bodies, not the governing bodies, the professional bodies. So we have a few there like IEM, MySet, IMM, Institution of Mechanical Engineers. This is in the United Kingdom. IEEE, Malaysia section, and then you have CIBSE and IET. Next slide. Okay, some more information on these professional bodies in Malaysia. As I mentioned, the Board of Engineers Malaysia is a regulatory body for engineers under the REA, Registration of Engineers Act 1967. And then you have professional bodies like IEM, which is a voluntary professional body supporting the development and recognition of engineers. And then you have MySet, so IEM in Malaysia, MySet also in Malaysia, Malaysian Society for Engineering and Technology. which is a multidisciplinary engineering society promoting professionalism, education, and public interest in engineering and technology. And then there is another 2 or 3 more, IMM, Institute of Materials Malaysia, which is a professional society and certification body that promotes honorable practice, professional ethics, and encourages education and skills in material science, technology, and engineering. And you have CIBSE, Chartered Institution of Building Services Engineers, particularly for civil engineers. Malaysia chapter, which represents building services engineers in HVAC, electrical, lighting, and related disciplines. And then there are a few other professional bodies in the United Kingdom. Here you have Institution of Mechanical Engineers. I believe there is also an Institution of Civil Engineers in the UK. And another one is the IET, the Institution of Engineering and Technology. This is also a United Kingdom institution for professional bodies. Next slide. Right, let's look at the engineering registration and practice in Malaysia. There are 5 floors there. 5 floors there. We will start with the ground floor or the first floor. And the first floor is to obtain an accredited engineering degree. So you are now joining institution of higher learning for an engineering degree. So the first step, the first floor that you need to achieve is to obtain an accredited engineering degree. Once you obtain an accredited engineering degree, you are now officially a graduate engineer. Of course, you need to register with the board. Once you graduate, you need to register with the Board of Engineers Malaysia as a graduate engineer. And then you can put the suffix after your name as grad-eng, graduate engineer, by the Board of Engineers Malaysia. And then you can get your 3 years experience. After you achieve the 3-year experience, you can apply for a professional status. So the second floor is after 3 years. So make sure that you register with the board immediately after you graduate, so that all your working experiences will be counted as your practical training. So your practical training will only be counted after you registered with the board as a graduate engineer. Then after 3 years, you can submit the form to apply for a professional engineer status. Then it means that you need to pass the examination, the professional assessment examination. That is going to be level 3. And then once you pass the PAE, the professional assessment examination, you can register yourself as a professional engineer, PE. PE. That one, once you get your PE, you will be given a stamp, a triangle stamp as a professional engineer. So it will be Muhammad Rafiq, professional engineer in mechanical engineering. And then after your PE, there is one final step, the highest floor, which is PEPC, Professional Engineers with Practicing Certificate, which means that now you can use your professional engineer status to sign forms as a consultant. Okay, so that is the highest floor. Next. Right, I think this is similar to what I've just mentioned in the previous slide. So there are 3 categories of engineers. The first one is graduate engineers. So make sure that you work hard, study smart, and get your certificate in engineering. Once you completed your degree in engineering, register with the Board of Engineers in order to get the graduate engineer status, the grad.eng.gradeng. And then after that, once you received your certificate as a graduate engineer, you can start your practical experience. Practical experience will only be counted after you receive your certificate as a graduate engineer. And then once you achieve the 3 years, once you completed your 3-year practical experience, you can apply for a professional engineer status. That is the second category. And the highest category is the PEPC, where you can now work as a consultant. Yeah. Okay. Next. Right. From this slide onwards, these are the registration process for the three status, for the three categories of engineers. The first one is graduate engineer. So who should register? Fresh graduates with an accredited engineering degree. So please ensure that the institution of higher learning where you completed your study, where you are studying now, is an accredited engineering program. Yeah, because you will only receive this graduate engineer status if you graduated from an accredited engineering degree. Okay, Washington Accord recognized. The registration process is online as usual, and you need to provide all these 4 items, simple items: the degree scroll, your IC, passport size photo, and a 50 ringgit registration fee. Once approved, you will be recognized as a Gradeng, GE, graduate engineer. And then next, okay. This is a BEM graduate assessment program. What this is basically if the type of program that you currently enroll in is a local MQA accredited 3-year BEng, 3-year BEng, or a 3-year BEng accredited by Engineering Council. If you graduated from the United Kingdom, most likely the degree is a 3-year degree, engineering degree, or an EEED, first cycle tier degrees. And then you must attend this BEM graduate assessment program. Yeah, as well as if your 4-year engineering degree was not from a Washington Accord signatories, then you must add a BEM graduate assessment program in order to be registered. Yeah, because previously the 3-year local engineering program is not recognized. So in order to be recognized, you need to have an additional studies, additional engineering studies to be completed, and then only you can register as a graduate engineer. Next. This is engineering technologist. So engineering technologist is not a full engineering program, engineering degree program, but you can still register as an engineering technologist if you have once you have an academic qualification of an engineering technology degree. Provide that certificate with your IC, passport size photograph, and payment, and then you can register as an engineering technologist, which later you can become a graduate engineer. Yeah, so if any of you following this webinar is currently attending an engineering technologist program, you can register as a graduate engineer later on. Yeah, so not immediately, but later on. Yeah, because you need to meet the academic qualification requirements under the REA, under the Registration of Engineers Act, Section 10(1). In the previous, in the very beginning of my presentation. So these are the requirements that need to be fulfilled if you are graduating from an engineering technology program. Next. Again, same conversion of engineering technologies to graduate engineer. So if you are attending an engineering technologies program, fear not. You can still register with the board as a graduate engineer once you fulfill the requirements. Okay, so further learning via a master's degree for registered engineering technologies shall cease and be replaced by BEM-GAP. So Board of Engineers will no longer accept master's degree. You must attend the BEM graduate assessment program starting from January 2023. So about 23, 24, 20, about 3 years ago. Yeah, about 3 years ago, we have decided that if you want to convert from an engineering technologist to graduate engineer, or from a non-accredited program, you must attend the BEM graduate assessment program. Okay, and it says there, uh, you must register in the same branch as the engineering technologist degree. Credit transfer up to 30% if you attended a 3-year program. If you attended a 4-year non-accredited program, then you must take the BM graduate assessment program. The difference would be that the credit transfer will be 50%. Yeah, so it's if it was a 4-year program, then 50% credit transfer. 3-year program, only 30% credit transfer. Okay, next. This is another registration process, but for a professional engineer. So who should register? Someone who has already registered as a graduate engineer and already fulfilled the 3-year practical experience can apply for a professional engineer status. And you must have a design and site work for 12 months if you are graduating from a civil engineering program, and must be supervised by a registered PE in the same discipline. And you need to prepare and submit the application form, training and experience report, competency report, and logbook, and sit for the PAE, for the professional assessment examination, which includes a 15-minute project presentation and an interview with a written exam on code of professional conduct. Upon passing this PAE, this professional assessment examination, you will be given the suffix IR. So you can now use IR before your name. And this is tier 1, professional engineer tier 1. Next. And then this is PE tier 2, which is professional engineer with practicing certificate. Who should register? A professional engineer who wish to sign, submit, and certify engineering plans and drawings. So this is a higher standard. So in order for you to approve or to prepare a plan and approve a certain plan, a certain drawing, you need tier 2 PE. Tier 1 PE cannot do the signature, submitting, or certify any engineering plans or drawing. Yeah. So you need to be a PEPC to do that. Professional engineers with practicing certificate. How to qualify? You must already be a PE and sit for and pass the PCE. So this is another examination, the professional competency examination, which focus on higher responsibility and public safety. Then when you pass this PCE, professional competency examination, you can sign, submit, and certify any engineering plans and drawings related to your discipline. Next slide. Okay, this is my last slide. There are 6 items to this slide. I would say that these are important items, engineers' responsibilities. Now, the keyword there is uphold public safety, maintain professional competence, adhere to ethical standards. Next slide, let's go through all the 6. Comply with laws and regulations, maintain professional competence, supervise, and mentor. So all these 6 must already be in your head, yeah, when you start your engineering degree. Now, the reason being that when you attend your studies in engineering, we actually give you the capabilities to create magics, to create wonders. Yeah, we basically give you the tools for you to develop a country. Yeah, don't misuse them. Yeah, by following these responsibilities, these 6 items, we have to ensure that engineers don't behave unnecessarily, because the knowledge that you will acquire within the 4 years of your studies in engineering will allow you to do magics, to develop certain things, to create new wonders, so we don't want you to misuse the knowledge that are given to you in the 4 years engineering degree program to do something that you're not supposed to. Okay, so those are the 6 items. Yeah, uphold public safety, maintain professional conducts, competence, and adhere to ethical standards, and so on. So that's all my presentation. Again, thank you again for listening to my talk.
Thank you, Prof. Dr. Rafiq, for the comprehensive and informative session. We'll go straight to the question. The first question is, why is it important for engineers to be officially recognized or registered?
Because we don't want any Tom, Dick, and Harry to do this engineering job. Because you can actually do something even without attending to an engineering course, engineering program in an institution of higher learning. So it is very important for you to be accredited, to join an accredited program, because it has a complete package, not just the knowledge on how to do things, but why you have to do it and how to do it properly. Yeah, so that's why you need to have first of all attend a degree that is accredited, and then once you are accredited as a graduate engineer, then you can start practice and then apply for a PE. So the Board of Engineers actually look after the profession itself. Yeah? We don't want something bad to happen, because with the knowledge that you have from the degree in engineering, you can do a lot of stuff and damage people as well. Yeah. So there are good things about engineering, and there are also not things that are not that good that engineers can do with the knowledge that they have. So attending an accredited degree means that you have the knowledge, not just the technical knowledge, but all the other knowledge necessary for you to become a responsible engineer. So that's my answer.
Okay, what kind of responsibility do engineers typically have in Malaysia?
Okay, responsibilities actually to advance and to help the society. My discipline in particular is biomedical engineering. So I can give you an example directly related to biomedical engineering. When we talk about biomedical engineering, we develop devices to assist patients. Yeah. So basically, we assist medical doctors. We get inputs from medical doctors, and we design devices that can help medical doctors to assist their patients. Yeah. So that is the kind of responsibility. I mean, it is a huge responsibility, because there is a lot of stuff that are not readily available to medical doctors. Yeah, they have the certificate to do surgery, for example. They know anatomy and physiology, but as far as developing devices are concerned, they know nothing of. So that's why they need engineers. So in particular, biomedical engineer, I mean, a biomedical engineer would understand what medical doctors are saying. So we can get some input from medical doctors, and we need to somehow develop tools so that the medical doctors can actually use on their patients, or develop tools that can be used directly on patients, of course, with the supervision from medical doctors. So these are the kind of responsibilities for an engineer.
Next question, what are the biggest barriers engineers face in implementing green technologies at scale, and how they overcome?
Green technologies at scale.
Yes.
Green technologies. This is part of SDG, Sustainable Development Goals, which we also embed in our accredited engineering degree program. Yeah. Green technology means that we need to look after our planet. We need to look after the environment. And there will be at least one specific course in your engineering degree related to this. Yeah, related to the SDG, Sustainable Development Goals. What is the challenge? The question is, what is the challenge of implementing green technology at a global scale? Now, when you want to develop something, the thing that you should be concerned of is whether this will be damaging to the environment or not. If we can actually develop something that is also environmentally friendly, yeah, that would be the aim, yeah, the aim. Because previously we can just build anything. You can build an engine, a car, yeah, an engine. But the challenge now is how do you create an engine that is safer to the environment, that is green, yeah? Should you convert to from a internal combustion engine to a battery, yeah, electrical battery car? Yeah, that is the kind of shift when we talk about green technology at a global or a larger scale. It is certainly a challenge because not all technologies that lead to green environment are cheap. Not all of them are cheap, are readily available. So getting the resources, converting them into something that is safe to the environment is still a challenge, I would say.
Thank you, Dato. What common misunderstanding do students have about engineering practice?
Common misunderstanding. That is an interesting question. Common I guess the thing that I normally receive, the kind of questions that I normally received from my students, is that what is the difference between an engineer and a technologist, engineer and a technician? Yeah. So these are things that perhaps they are not very certain of. Because they would say that, let's say if they go to a lab, for example, if they ask the lecturer about the usage of a certain equipments, then they say that it is better to ask a technician, than a lecturer who already has a PhD and a professional status. So in that sense, they would argue that does it mean that a technician is better than an engineer? So that is the kind of confusion or misunderstanding perhaps that that I receive from my students, at least. And the thing about being an engineer is that we actually design that equipment. Yeah, we are the one who designs the equipment. I mean, maybe not the equipment that we have in the lab, but we have the capability, the tools, the knowledge to design new things, to develop new things, to innovate. So that's the reason why the only way to develop a country is to have lots and lots of engineers, because engineers will utilize the knowledge that they have to innovate, to create new stuff. Yeah. So the common misunderstanding, I would say that they would argue that it is just the same. An engineer and a technician is the same. I guess to me, the kind of questions that I normally receive from my students. And I would say that no, that it's a two different thing. You know, being able to innovate is the one who is the one capable of developing a country. So it's a huge difference.
All right. Are there differences between working in government, private companies, or universities?
Governments, universities, private companies. Yeah. So
Yes.
three items there. That is, we normally use these three things in a triple helix. Triple helix. I mean, I'm not sure whether our students are aware about triple helix, but triple helix basically is a combination or a collaboration between three important entities: universities or academia, government, and industries. Yeah. Are there any difference? There are some differences, definitely. Definitely there are some differences. If you work in an institution of higher learning, you basically involve in developing new knowledge, imparting those knowledge to students. Yeah. Train new engineers. So that is if you choose to join an academia. Yeah. If you choose to join academia like myself, you know, I'm a lecturer in engineering, so I need to create new knowledge of engineering. That's number one. And number two, impart, basically teach the knowledge that I have to students at a higher degree. And number three, to impart basic fundamental knowledge to undergraduates. Yeah, so that is number one. If you want to join academia, if you want to join private companies, then I would say that it is not about imparting new knowledge. It is not about creating new knowledge. It is about developing, producing engineering products. Yeah? Developing, producing engineering products. And then sell them, of course. Yeah, that's when you join a private company. So a totally different agenda, a different KPI. If you join academia, the KPI would be about creating new knowledge, publish your knowledge, make sure that everybody is aware about your new knowledge that you created. Yeah, but if you join private companies, then it is about making profits, developing new products. Yeah, whatever product that you have, you need to add on so that you have a version 2, version 3, version 5. Yeah, so that people will be very happy with the products. People can actually utilize them in their daily life. So that is if you want to join private companies. And the third one is government. Now, government relates to policy making, which I would say a very important component as well. Because without this policy, without these regulations, you cannot have the engineering program or engineering graduates to perform at their best, at their very best. Yeah. So the three components are important, and no matter which one you join, either you join the government or you join a private sector or you join as an academia in an institution of higher learning, you play different roles, and these three roles are important.
All right, thank you, Dato'. What advice would you give a student about entering the engineering profession?
Advice, engineering profession? I would advise them to, I guess I would say the same as what Dato' Rahim mentioned. It's about lifelong learning, isn't it? So when you join this profession, there is always new development, new technology. And we entered into the era of the fourth industrial revolution. We have now AI, artificial intelligence, and so on. So, and we also, in universities, we also incorporate this new technology, yeah, into our engineering degree program to prepare our graduates for the future. So I would say that lifelong learning, always keep your mind into something new and beneficial, and think of how you can benefit others with the information that you have.
Thank you so much, Prof. Dr. Rafiq, for the enlightening presentation and discussion. We will now proceed to our next module, module number 3, Engineering Ethics. This will be presented by Yang Bahagia Datuk Seri Profesor Engineer Dr. Kamal Nasruddin Mustafa. Yang Bahagia Datuk Seri Profesor Engineer Dr. Kamal Nasruddin Mustafa is a practicing civil and structural engineer with specialization in structural and fire engineering. He previously served as Vice Chancellor of University Tenaga Nasional Uniten and currently holds the position of Chairman KTS Management Consultants in Merhab. He also a council member of the Engineering Education Council EAC. In addition to his academic and professional role, he serves as the chairman of Humanitarian Care Malaysia, MyCare, and remains actively engaged in advancing engineering education, institutional leadership, and national higher education developments. His contribution continues to shape both the engineering profession and the broader academic landscape in Malaysia. Please welcome Yang Bahagia Datuk Seri.
Thank you, Engineer Zairul. Assalamualaikum warahmatullahi wabarakatuh. And thank you for the kind invitation that extended to me to speak on engineering ethics this morning. And thank you to students from various ISLs, institutions of higher learning, for making time to attend to this webinar. Next. My presentation online is as displayed. I'll be speaking more on ethics and professionalism. But let me say from the outset that engineers are vital to shaping the world. We shape the world, we develop the world, whether it's telecommunication, whether it's transportation, whether in construction, whether in oil and gas, as expounded by Dr. Rahim, whether in medical engineering, as shared by Prof. Rafiq, we contribute to the civilization and we shape the world. So it's very important that we build confidence in engineering profession trustworthiness so that society at large will have trust in us to ensure sustainability of the profession. And hence comes in the issue of ethics and professionalism. So my focus is on that two aspects, but I will also peruse through issue of engineering example, case study briefly, and also code of professional conduct and consequences of neglect or negligence. Hopefully it won't happen to all of us. Next. Ethics, as I understand it, and probably I may share this with all of you, it is a set of moral principles which help us discern or differentiate between right and wrong. So it's important to stress from beginning that ethics is set of moral principles, and hence there will be the issue of right or issue of wrong, and at times will be legal consequences if we do not adhere to the ethical practices. Whereas professionalism is more of action or good behavior or good judgment. Say, for example, if I may use this example to briefly elaborate issue of ethical, and forgive me for say because it happens. It's a lawyer who take money or steals money from client's trust account. That particular lawyer may lose practicing certificate because of his or her unethical conduct or misconduct. So you can see that when issue of unethical, there can be consequences, very heavy consequences on a particular person. When you talk about professionalism, it's more of our act, our conduct, our behavior or judgment. For example, sometimes when we do presentation, the students do a lot of presentations. People may disagree with us, criticize us, and highlight any of our weaknesses. But we cannot be emotional about it. We have to be professional. So you reply with data, with your argument. So this really differentiate between ethics, set moral principles, and professionalism is conduct, good judgment, or good behavior. But for all intents and purposes, these two are intertwined. You can never say that ethics is important. I'm not worried. I don't think it's professionalism is important to any of us, or vice versa. Both are important. You cannot separate ethics and professionalism, and that's the way that we conduct. So I will always, I believe that if you are engineer, say, because my background is civil structural engineering, so you build structure, you are very good in structural engineering, you are good in design of structures or in water supply. That's okay, that's very, very good, but it is underpinned by ethics and professionalism. And hence, that actually will ensure sustainability of the profession, the trust that we gain from public and from society at large. And it is also important for me to highlight here that at all times we hold paramount the safety, health, and the interest of the public. So that's a very very big statement, very heavy statement that I would like to share at the beginning, that at all times we hold paramount the safety, health, and the interests of the public. Hence, within this context, it comes the issue of ethics and professionalism. Next, as I was saying, professionalism is about conduct, about behavior and judgment. So all engineers, I would say, students, when you graduate, we are technically competent, and even more so when we develop our career with a few years experience, we are even more technically competent. But being technically competent, we may not get the trust of society. It comes with we have to process ethical and social responsibility. So that way, the trust from society will come. So we have to comply with the regulations. We have to ensure public safety. We have to address social concern. We have to develop respect for others, especially for our colleagues in engineering profession. We have to uphold integrity, loyalty, and transparency. So having technical competency is important, yes, it's so very important. But for us to gain the trust of the society and ensure sustainability of the profession, we have to comply with all this legal compliance, as I was saying earlier on, ensuring public safety, address social concern, develop respect for us, and so on. Next. Sometimes we feel, and I was teaching engineering before at university. We have to actually share with students that we talk about ethics and professionalism. It's not that it comes in when you start your career. No, it actually starts when you are in universities, when you are taking your degree programs, when your first year, second year, mechanical, electrical, chemical, or whatever programs, any programs that you take. As the proverb says, or the adage says, that charity begins at home. So you don't, you have to imbue this issue, ethics and professionalism, while you are in campus. So this some of the examples that we have to be mindful of: academic integrity. So we have to ensure that and also source citation when you prepare reports or publish any reports. You have to be mindful of the intellectual property of the source of your data. So that is ethical practice, and you have also to work in group, work as a team, and this is where you develop your leadership skills, communication skills, respect for each other, and other things. Continuous learning was highlighted by Datuk Rahim and Prof. Rafiq previously, that it's important that we go for continuous learning, not only for our personal development, for self satisfaction, but also to contribute more to society. You have to be engaged in community. Certainly through community engagement, you understand the pride of the people outside campus, and it will develop us to be a better person, especially so when you wish to become a leader. We will become leader in our own right while you're in university, and also when you complete your studies. Another point is professional participation. Forgive me for not following the order, but professional participation is important. I would strongly recommend students, while you are in campus, do involve in clubs and societies. you have your ICE branch, or IMECI or IEM or whatever society in campus, do get involved. This is where you learn about the trades, about engineering profession, and also be involved, and opportunity to get in touch with experienced people who may come to campus and share their experiences with you. So please do involve in this club and societies while you're in campus. So if I might summarize this on this slide, is that the charity begins at home. So you've got to start developing and understanding about ethics and professionalism while you are in campus. Don't ever feel that, okay, it is an issue that of concern when you work. No, you have to start early. Next. There are many issues in life, that gives we are very sad to hear and to see it happening, whether locally or internationally. So this example, number one, a chemical plant dispose waste in a landfill, or certainly over time, dangerous chemical was seep into underground water and nearby river. So the plant engineers were aware of this issue, but did not take any action to change this disposal method, because maybe it may become costly, because it may take time, because it got the process for getting approval will be very lengthy. So then nothing changed. Initially, the local authorities were not aware of the danger, but over time, either the people or society or local authorities will come in, then you will be in trouble. Or the company, the factory will be in trouble. The person in charge will be in trouble. This because we compromise. We do not adhere to ethical conduct. So please be mindful that you cannot compromise safety of the people. We cannot compromise the integrity of the profession, not at all costs. So the best, of course, is to follow the provisions provided for by local authorities, and also the provision provided for by our engineering profession. So do not at all compromise on ethical behavior. We have to uphold ethical conduct. Next. Example two is a faulty machinery. Is also, I think, it does happen, but I hope in future we'll be more vigilant about this, and cannot be party to this misconduct. Technician discovered faulty machinery and applied to stop its operation, but the superior viewed this as minor, insignificant, and continue to operate, remove the tag, and then worse is that the technician who wanted to correct the situation was subjected to the disciplinary action. I know, in instances whereby the machinery was faulty, and eventually the person or the working in the environment was got injured. If within the context of a university, you have heavy structure lab, so overhead crane, so you have to be to operate the overhead crane. You have to have the license. So it happened once many years ago. It was a faulty machinery. Then it caused death to people working in that environment. So the repercussion is huge if we compromise on safety, health and safety, if we commit unethical behavior. So be mindful of this. So it's important that we highlight this example. There are many other examples, so as to ensure that it won't happen, so as to ensure that at all times safety and health is paramount to all of us. Next. In anything in life, you have to have some form of regulations. In engineering profession, there's Registration of Engineers Act 1967. So that define the process for registration of engineers. So only qualified registered individual can practice engineering. Prof. Rafiq was mentioning earlier on, not anyone can come and claim that I'm an engineer, let alone a professional engineer with or PEPC. So you have to go through the process. It is end-to-end system, complete tested system that you have to go through from university days, and you got, if you want to be a professional engineer, there's examination, PAE, and so on, that you have to go through. Then only you can practice as an engineer. Of course, there are category of inspector of work or engineering technicians, engineering technologists, or graduate engineer, professional engineer, or professional engineer with practicing certificate. There are process and procedures that we have to follow before we are deemed to be qualified and registered individuals. So please do follow this process and procedure. I will suggest that as much as possible. Hopefully, all of us will eventually register with Board of Engineers. You have to register with Board Engineers, and then you become a professional engineer and with PEPC, inshallah. But having said that, there is also provision for disciplinary action to be taken against those who violate professional standards and conduct. So whether you can be suspended or your registration can be cancelled and so on. So next. These are the various acts and legislation. Why is it acts and legislation important? The overarching thrust of the Malaysian acts and regulations has been to safeguard Malaysia's national interests and protect public safety. So all of these acts and legislations the purpose is to protect our national interests, to protect public safety. But each and individual acts and regulation will have their own specific purpose. Say if you talk about OSH, it's about safety, health, and welfare of people at work. So if we talk about CIDB, talking about the protect the people and the process involving construction industry. So be mindful again. We have all these acts and legislations that we have to follow because at the end of the day, the overarching impact is trust is to ensure public safety. Next. Registration of Engineers Regulation 1990. This is actually, there is a revision in 2015, and this is subsidiary to registrations of Engineers Act 1967. But basically, this is more on the code of conduct of us engineers. You have to we have to be responsible. We have to be act honorably and lawfully, and we have to be responsible to our employer, to our client, and our profession. As I was saying earlier on, at all times, hold paramount to safety, health, and interest of the public. We have to discharge of duties of fidelity. You have to be honest. You have to be faithful to our profession, and also we have to maintain and protect the reputation of this profession. At no time we can maliciously injure our fellow colleagues in any way. So it's important that we protect the reputation of our colleagues in engineering profession and also protect engineering profession as a whole. Next. Registration of engineers, Regulation 1990, Part 4, as I was mentioning earlier on, this is a subsidiary of the Engineers Registration Act 1967. So it mentions specifically in Regulation 27, prohibiting canvassing and advertising. I think normally when we advertise, normally it's about self-laudatory. You know, we advertise with self-laudatory, meaning that we praise ourselves, we praise the things that we do at the expense of our displacing our other engineers or colleagues. So this is not allowed. Self-laudatory, praising ourselves and displacing other colleagues, that is not allowed. So Regulation 27 of the Regulation 1990 Part 4, conduct of professional and engineers prohibit us from undertaking this advertisement. But you may, get approval in certain cases, but not at the expense of displeasing our profession and displeasing other engineers. Next. Again, conduct of professional, you look at the Regulation 2031, if I may summarize, it's about system and orderly. We have to support, supplement, we have to work together, we have to practice, and do not in any way take over the work of our other colleagues until there is clear passing over of the work from the previous consultant or engineer, passing it to us, or the client itself issue a written approval for any one of us to take over the job, taking over from previous engineers. So we have to ensure, within the context of ethics and professionalism, we have to ensure the systems we have maintained the system, orderly system in our practice. Whereas in Regulation 32 and Regulation 33, it's about to avoid conflict of interest. You cannot be in engineering consultancy practice. You design, facilities, but at the same time, you sit on the board of the construction company. So because this may lead to conflict of interest, but you need to get approval for you to sit or to hold shares or to be part of the construction company or manufacturing companies. You got to get approval from board of engineers, but only then you are allowed if it is a design and build concept. Otherwise, you are not allowed. But the issue is mainly to avoid a conflict of interest. Next. Again, I was saying earlier on, who when we say registered person, who are they? Professional engineer with practicing certificate, professional engineer, graduate engineer, engineering technologist, and inspector of works. And this is stipulated in Board of Engineers Circular 01/2016. So clearly defined who are, when we say registered person, who are they? Next. Again, on code of conduct, the issue is so very important for me to highlight that you should never certify any work until you are sure that is safe, that is orderly, and you have control over its operation. So there are cases where you say, "Oh, I trust you, so can I sign? Can I certify the work?" So based on what, let alone this hearsay, then you put your signature to. Please do not ever do this. You can only certify any work for that matter if you are sure that is safe. You have control over the operation. You have witnessed or inspected such work. Otherwise, you may lead to some problem which may come later on. So this is very important when you certify any work. Next. Consequences of neglect, or no, you know that when we design any facilities, we design for intended purpose, we design for safety, and of course, design for cost. It cannot be exorbitant. There's always limit to the budget, the cost for any particular facilities. So again, our duties as engineers, we design for purpose, for the intended purpose, safe, for safety, and also be mindful of the cost. So if you commit error in the design, or you in the supervisions, or you do not adhere to principle of ethics and professionalism, the consequences can be huge. It's something that we cannot just take for granted. Loss of life, it will be legal liabilities, it will be legal repercussions. So, these are huge, which may impact us or may impact the profession. But loss of life is something that's very worrying. So in no circumstances we should, or we neglect, or we disobey the ethical practices, which is so very paramount. Next. Case study again, this is Silent Tower, happened so many years ago. It is the issue, the underlying ethical issues. It was built in unstable terrain, insufficient drainage, and also a slope stabilization measures were not put in place. So hence the collapse of Highland Towers over the years after it was constructed, and sadly 48 people died in that incident. So significant implications that engineers and building professionals, we have to emphasize on the need for ethical practice, and we have to follow the regulations put by local government, and again, as I was saying earlier on, that we have to ensure safety and stability and integrity of the facilities that we build, and we have to share, take responsibility for what things that we do. Next. AI ethics. AI is the thing now. So artificial intelligence. So we know that now computer can mimic or can do things that replace human intelligence, but then there is the AI ethics to ensure that we do not actually compromise again on anything. This example or mentioned about a senior employee in the UK. He used an AI generated deepfake call, or he relied on it at the expense of instruction from his superior, so which had caused some problem within the environment he was working in. So be mindful while you leverage on technology. It should not in any way compromise on ethical issues and our professionalism. So if I'm at next. Next. So, okay, to summarize, I think the topic here is on ethics that I shared with all of you, is about ethics and professionalism. You have to be mindful that we carry a big responsibility. Forgive me for saying this. If you're a doctor, maybe, if you do wrong, one patient may suffer. Hopefully it won't happen. But if you're an engineer, you design facilities, or say example bridges and buildings and so on. So the suffering, not one or many people may suffer because of mistake that we do. So please be mindful about the safety about health and integrity of the public. All of the things that we do, we design facilities, it should be underpinned by ethics and professionalism. Thank you very much for the time given.
Thank you so much, Dato Sri. We're going to go to the Q&A now quickly. The first question is, what should a young engineer do if asked to do something they feel is wrong?
You have to stay true to your profession, to the issue of ethics and professionalism. If it is wrong, it's wrong. In no way that we should compromise our principle. We have to stand up to our principle and to protect the bigger interests of the people of the society, and to ensure to protect the interests of the profession. I was saying and sharing example before, when you compromise on issue and this issue of safety, when you do not uphold ethical conduct, then there will be repercussions sooner or later. So we have to avoid all this at all costs. Stand to your principle.
Okay. What step can engineers take to ensure their decisions remain ethically responsible in challenging situations?
If you follow the guidelines, the provisions stipulated in whether in our code of conduct, whether in provisions provided for by local authorities, and you follow them throughout your design, your implementation of project, then you're okay. So stick to the rules and regulations, stick to the instructions given, but never ever compromise on this matter.
Okay. How can students learn to act professionally even before graduation?
I will encourage. I was mentioning earlier on, while in campus, I think it's important for students to be involved in clubs and societies. There are many, IEM branch chapter, ICE branch chapter, IMECI, or some other club societies. This is where you develop, some skills, soft skills. Mentioning by Datuk Rahim was mentioning about the importance of developing soft skill, about leadership, communication, and more importantly, club and societies normally will organize professional engineers to come to university and share their experience, or club and society will organize activities bringing students out of campus to visit some site under facilities under construction. This is where you get exposure, early exposure on issues related to ethics, professionalism, and about challenges that you may face in industry. Please don't leave it too late. Please don't think that, I'll get this when I start working, then I'll get all the skills, the exposure, the knowledge. No, it is best that you get all this while you are in campus and you have ample time. You take engineering 4 years, please do spare time to be involved in clubs and societies. And the universities also will, encourage volunteerism. So it's important for students to volunteer in works in campus or also outside campus. And this is, you build your character as a professional, future professional engineer while you are a student in campus.
Right, last question, Dato Sri. How can engineers balance cost-saving decision with maintaining safety and ethics?
Sorry, say that again, Engineer Zero.
How can engineers balance cost-saving decisions with maintaining safety and ethics?
Oh, this is a special skill. I was sharing earlier on is about when you design facilities, you design for the intended purpose of safety and cost. A lot of discussion, a lot of check and balance, a lot of revision work. But all in all, you have to listen to suggestions, to opinions, and you have to listen to advice from your senior engineers. And this is way forward. Never stop learning, never stop discussing, never stop working as a team, and never stop learning from your experienced engineer. And your trajectory will be a lot faster if you adopt this approach, rather than you isolate yourself in silo, from keeping yourself away from your team members, from listening to advice of people.
Thank you so much, Datuk Sri, for your insights and response. We're going to move on to our last module this morning, Engineers and the World. This will be presented by Engineer Magat Johari Magat Muhammad Noor. Yang bahagian Engineer Magat Johari Magat Muhammad Noor is a distinguished figure in Malaysia's engineering committee. He currently serves as the president of the Malaysian Society of Engineering and Technology Mindset, a board member of the Board Engineers Malaysia, and the deputy chair of the Engineering Technology Accreditation Council, ETAC. He is also a former chair of the Engineering Accreditation Council, EAC, under BEM. He played a pivotal role in securing Malaysia full signatory status under the Washington, Sydney, and Dublin Accords, strengthening the international recognition of Malaysia's engineering qualification. An accomplished academic, he has published more than 300 papers in the field of environmental engineering and engineering education. At the international level, he made history as the first Malaysian appointed as chair of Dublin Accord under the International Engineering Alliance, IEA, making significant milestone for the nation in global engineering education leadership. Please welcome Engineer Magat.
Thank you, Engineer Zairul. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and very good morning to all. I know that it's been a long journey for you this morning. Being the last speaker of the session, I hope you can still pay the attention. Now, the outline of my presentation generally would cover the introduction to engineers and the world. Now, when we talk about engineers and the world, it is not just engineers, but rather the engineering personnel, those who actually contribute to the world itself in terms of engineering. Now, the other will be the responsibilities, and we look at the sort of multidisciplinary knowledge that is required and other knowledge that would enable us to actually propagate or ensure sustainable development to be considered seriously by engineers. And last but not least, we'll be looking at the impacts on the engineering solutions, as well as of course, some of these are already covered by the previous speakers about the local and federal authorities in terms of these standards. Now, briefly, really, we are highlighting something that is quite, one would say, not so much being put emphasis in the past. Many a time that we tend to focus on technological prowess or more of the technical knowledge one or an engineers should have, but rather the soft skills or the other effective components are not really being addressed. So here we are talking about the outcomes number 6 under the Engineering Accreditation Standards or ETAC standards, where it actually calls for us to focus on the engineers and the world itself. That means to say we cannot forget that when we produce solutions, we are actually doing it for the society, doing it for the world, doing it for the environment, really. And we have to ensure that all impacts related to all these would be mitigated. Next. So there are a number of standards that are available, and PO6, it's common to all. The common stem here, when we say about PO6, which is about engineers and the world, it's common in the sense that every one of us, whether you are engineers, engineering technologists, or engineering technicians, which the board call IOW at the moment, they are supposed to ensure that sustainable development is being considered in any of the solutions that they provide. So here, evaluation, analysis and evaluation, at least for the engineers and the engineering technologists, but for the technicians, they will need to look at how the impact on the society takes place, because the technicians tends to be assisting the engineers and the engineering technologists. So sustainable development becomes more and more important. I mean, it used to be, we hear about the Millennium Development Goals. Now you have the 17 SDGs, Sustainable Development Goals. And all this is actually trying to bring us to one thing, which means to say we shouldn't be compromising the future generation in terms of what we are reaping at the moment. So the environment has to maintain as what we are reaping now, and that's all about sustainability. So that means to say any development work that we get involved in, we have to ensure that it's not going to ruin the future generations being able to actually experience what we are experiencing now. So that's the crux of it. Next. Now, there are 3 knowledge profiles, one would say, WK1, 5, and 7. But it is more about integrating a number of knowledge, not just purely engineering knowledge. For example, if you look at WK5 here, it's all about making sure that when you do design, you consider all these aspects like whole life cost. That means not just looking at the initial cost, it's about life cycle. Look at possibility of reuse of resources, or even looking at the net zero carbon and other concepts. And all these are sustainable concepts that brings you to a better sustainable development in terms of solving problems. Whereas WK1 is all about the natural sciences and the awareness on the social science. So we cannot run away and say that, we'll just focus solely on technical aspects. But here, the importance of understanding natural sciences as well as social sciences would enable us to navigate in solving the problems. Now, if you look at some of these important aspects on WK1, I'll just give you an example of the environmental science. We tend to, for example, if you are looking at solving wastewater treatment plant design, then you should understand that how is it going to impact the overall ecosystem of what you are trying to discharge? So in a sense, can you start to minimize the environmental impact? So that's the thinking that we should be having. That's the consideration. And then when we look at integrating social sciences in it, which is more important, like there was a question asking about balancing. So when we talk about transportation, is it all about making sure everybody can have access to it and reduce possibly the potential pollution as well in the future? Or is it the cost that becomes more important? So that's the sort of balancing, the thinking that we must be having when we are trying to solve this problem, right? And that's the very reason why social science awareness is actually important as far as when we are delivering engineering projects. Next. So when it comes to aspects like, how do you manage your resources? So in fact, engineering, if we talk about life cycle analysis that is being done, it is important that we look from basically cradle to the grave, really. And we think about when we design for the environment, safety of the environment, safety of people. And then we talk about how do we minimize, or rather prevention if possible, and then about efficiencies that we need to put in and conservation works that needs to be done. So these are considerations. And it's not just a matter of solving such a problem without thinking about what could be the possible impact. Next. Now, one of the things that becomes important for engineers has been sort of iterated and reiterated by the previous speakers is all about public safety. It's about responsibility to public safety. Now, it deals with, of course, integrity, it deals with ethics, but it also deals with we being able to understand that the environment is important. What's going to happen to the environment, right? So sometimes we are just concerned about our internal or small environment, but we do not look at large and how it affects. Just like, for example, the haze problem. Sometimes we say, oh no, that's the across the border. But haze doesn't know borders, right? It just moves. So you see, when we think about solving problems, we have to also consider what happens to our neighbors, right? What about the stakeholders? We need to think about them so that when we solve problems, we are solving, not transferring problems. You know, sometimes we do transfer problems. The other thing about the solution, or the impact that we need to look at. So these are amongst the things that we will have to consider. For example, the effect on the ecosystem, compliance to the law has been mentioned quite a lot just now, and about the safety aspects, quite important. And the other thing that we need to also look at is the long-term impact on the environment, not just the immediate impact. You know, sometimes when we look at environmental impact assessment, they tend to focus more on the immediate ones rather than the future. They do mention about mitigation, but then who actually follows the plan in some cases? Financial implication is important, but that used to be the only one that determines the solution at that one particular time. But what is important here is to look at all the options that we have and then do that balancing act. And impact on the community and culture, we seldom put much effort, but we have to understand there are things that are sacred to certain community. Just to give an example, there was one time that a company that wanted to actually build a water treatment plant, but taking in water coming from areas where the piggery waste is actually being dumped into the river. So you'll find that it is not acceptable to some, right? So we have to think about what is the culture as well. And that means to say the societies have the say as well, and they may not use what you propose. And it will not be solving the problem really when it doesn't meet the needs or the cultural aspects of the society and the environment. Okay, next. This is just another aspect where if you talk about the supply chain and marketing and so on, you'll find that whatever you do, there is going to be an impact, right? But what more important here is it all about saving costs? Is it all about making sure that you have grand infrastructure and yet no one is willing to actually use it? Or are you talking about trying to be efficient? But of course, being efficient sometimes means to say you are actually limiting the economic gains. So these are, again, the impact, the analysis that needs to be done when coming to the trying to solve these, the engineering problems. Next. Now, sustainability issues could be related to resources. We know that even now that we are talking about maybe rare earth in Malaysia, right? So that's going to be a depleting resource. So how do we deal with that? That's as engineers, right? Maybe as policyholders, they may have other things to consider, but how do we actually manage to sort of implement something that is not going to be a resource depletion? Pollution as a result of things that, you know, whether you mine it or you use it or you produce something that produces waste, or even resilient in terms of how does a building actually sustain in terms of if there are and then ecosystem impact, what happens when it comes to solving problems that you actually may cause the ecosystem to actually die out. The rivers or the ponds or the lakes may actually go dead. There's no life in there. So these are the things that you have to consider. So other aspects, what has been mentioned about the health and safety aspects, very much public health is paramount, right? And if we look at this, here it actually focuses more on the pollution aspects, but it is more than that. It also includes the occupational health. It is also design. You sometimes hear about designing for foolproof, right? Making sure that people do not actually make mistakes unnecessarily. It's human error. And the other thing that a lot has been emphasized on risk assessment. So mitigation is all about trying to mitigate the risks so that whatever design you come up with is a safe design and making sure that there are compliances. Next. The issue of legal and ethical consideration has been mentioned before, but intellectual properties must be safeguarded, making sure that you abide by all the regulatory requirements set, and making sure that you adhere to the contract that has been agreed upon. But I would like to highlight here about the liability. When you look at liability, if you do your risk assessment, most likely it will cover a lot of aspects to make sure that in the future, it's not going to fail on you. And it's not going to fail on the environment, it's not going to fail on the society. So these liability aspects becomes really an important necessity for you to consider when you are dealing in engineering works. Next. Most of the time in the past, we tend to we are more reactive rather than proactive, right? We were looking more of how to mitigate any losses. It's more of solving end of pipe problems. Try to solve pollution problems by treating it. But rather, we tend to now look at life cycle overall. How do we conserve the resources? That becomes a priority, being more proactive rather than defensive, reactive. Then that's the attitude or the approach that all engineers should be moving. Rather than building sometimes, we tend to actually create something, we create consumption society, but actually it is not conserving. So what is conservation becomes more important to us. If we do understand, then we will make sure that our solution is not about generating a consumption society, but in fact, it's more like making sure that we prevent disaster to the environment, prevent disaster to all the resources that are actually available for all of us. Having said all those, the relevant engineering laws and regulation has got to be met, and that has been mentioned earlier. But all these laws has got to be well understood, and especially so if you look at the environmental laws, you look about the health and safety laws, engineers have no other way but have to abide by all of them. So in fact, when you design accordingly and within what is required and supervise accordingly, you will ensure that your solution is going to be fulfilling the requirements of the policymakers, as well as the community, and making sure the environment is safe and sustainable for the future generation. Next. These are amongst the things that most engineers would have to dwell with. One good example is with the local authorities, whereby there are things like how do you control buildings, making sure that the land use is being done properly. In fact, environmental protection is being addressed. And similarly, in infrastructure development, appropriate actions or risk management has got to be done. So all these things are rules and regulation. That means as engineers, we must be fully aware about them and making sure that when we solve problems, as far as the legal requirements are concerned, being professionals, we have to abide by all those. Next. So in conclusion, one would say that it is important that in this sustainable, in fact, the world is moving towards this, although some countries may actually keep back, still are moving. But it is important that engineers, if we are really the problem solvers, we have to make sure that we solve problems, but making sure that the world is still sustainable. And that's why engineers and the world becomes important. It's the world that we're living in. It's not the small environment, the small world of our comfort areas. It's the whole world itself. It's a global challenge, and we are contributing to part of it, really, but making it eco-efficient, well-managed resources, and then making sure that we are responsible steward, as well as being professional, but not, in fact, all the while the stress has been technical prowess, but we have to actually bring about all these multidisciplinary aspects to be considered to make sure that our solutions are really developing a sustainable world. So with that, thank you very much to all for listening.
Thank you so much, Promagat. We're going to go straight to the Q&A. The first question is, how can students start thinking about the impact of their work on society?
It is interesting. If we get involved, actually, that means it is all about collaboration, starting with collaboration. And how do we collaborate? When we involve even at societies level, at the universities, or when we get involved in trying to, let's say, solve a project assignment that is being given, try to actually include all those. Try to talk to as many people as possible. Try to interact with as many people as possible. I think this will be the starting point, apart from just your own lecturers. There are others whom you can engage. And by doing so, you are building up that capacity to move along.
All right. Why is it important for engineers to think beyond technical solutions?
Right. Technical solutions may seem the easiest way out, isn't it? Because everybody knows all the fundamentals and how to design things. But your design, you have to remember that someone is going to use them. Say, for example, if I give a case like in Africa at one time, they were trying to solve the issue of how people not going to for proper sanitation, right? So, but then they found out, they tried to build a lot of latrines, but they found out that this particular community, they are quite claustrophobic. They don't like, everything to be enclosed. So then because of that, you start thinking, okay, how do we solve the problem where people will actually use the latrine? So they came up with an idea, let's have a latrine that does not have any doors. So can you imagine latrine without doors? No one is going to use it in Malaysia, right? But it is a spiraling one, right? You cannot see anyone inside, but there is no doors. You can just go in and out. But of course, there are other problems associated with that. But these are amongst the things that if we do consider, we take into consideration the requirements, then it will actually help in solving the real problem.
All right. Next question, how do engineers contribute to achieving the UN Sustainable Development Goal?
Yeah, there are 17 UN Sustainable Development Goals. Now, are we going to be able to solve all of them? But actually, if we look at it, all of them are actually relevant. But what will be our focus? Let's say if you're a civil engineers and looking into, let's say, clean water, then probably that will be one of the goals that is going to help people when you come out with a technology or come up with a plan that is going to make sure that public health is being, the public health in terms of safeguard is being done by virtue that you provide clean water. Now, if you are, let's say, someone who actually produce products, then if you use the products that, these materials are sustainable materials, then you are also contributing towards the Sustainable Development Goals. So the SDG could be divided into looking at what will the people benefit from your work, or looking at how can the nation progress and be prospering as the nation progresses, or you could actually look at from the point of view of the environment, how is it going to have a sustainable environment that is not going to be heavily polluted and not usable in the future, or you could see on the aspects of collaboration and partnership. So all those aspects are what we are supposed to be doing, but it may be some a major part, some could be as part and parcel of the everyday interaction that we have, and we build upon it. It becomes what some people say more like soft skills, especially when you need to talk to the communities, you need to interact with them to understand what are their problems before we can really identify their needs and to solve the problem.
Right. Why is multidisciplinary knowledge important for engineers today?
Again, when we look at this multidisciplinary, again, in the past, we tend to be very much not a prompt-based curriculum in engineering. And some people, I mean, I remember when my undergraduate days, they were questioning like, why are we learning about communication, right, in civil engineering? My background is in civil engineering. And many others, right, that we probably do not see the importance there. But if you look at multidisciplinary, for example, just like social science, right, understanding people is important. Even as an academic staff teaching, understanding the students is important to see whether they really understand how do they actually learn. So there are quite a lot of things that we need to actually include in what we are trying to do, right? For example, the social aspects that we talked about just now. Sometimes we do surveys, but we don't understand what are the basic requirements of these surveys when it comes to dealing with the social surveys. At the same time, for example, if we don't understand about the natural sciences, so we may not be actually addressing some of the important requirements, for example, mentioning just now about the geological requirements to be considered when it comes to seismic design. So natural sciences, things like social sciences, and many other discipline knowledge may be very useful. And sometimes these are non-engineering, right? And you can adopt them or adapt them within solving the engineering problem. And that's why multidisciplinary or even interdisciplinary is becoming more and more important. In fact, engineering has to include all those, otherwise we'll be left out.
All right, last question, Prof. What difficulties arise when balancing economic and sustainability factors in engineering decisions?
No, it's like a similar question that we had just now, right? Balancing. I mean, balancing is never easy. And balancing doesn't mean that is equal as well. Some people say, to justice is all being equal. But equal doesn't mean having, the same proportion. No? So we know that there are constraints, cost constraints, right? So that's why one of the things that engineers have to do is to make sure that we understand the limitation, but not to an extent that we are going to compromise on safety, right? And we shouldn't be compromising on something that is going to harm the environment, which is going to harm everybody at the end of the day. So that balancing act has got to be done. So there are a number of options that one has to consider, right? That's why we in engineering, you're being trained to come up with several options and to see what are the options that would actually, at the end, be a balanced solution. But of course, there is no end to trying to improve it. That's why things like value engineering sometimes is being added to make sure that you can optimize and save costs, but not to compromise on safety. So that balancing act becomes important. Even if you think about environment, I'm sure you're going to actually spend some money on something that is going to preserve the environment, because at the end, you do not want a treatment plant that is going to produce, let's say, odorous area that no one would want to pass by those areas, right? So again, you see, you may save a lot from the cost, but the environment is going to be very much affected at the end of the day. Thank you.
Thank you very much, Prof. Megat, for the very engaging session. We have a few more questions. This is a general question to any of the speakers, to either Dato' Rahim, Dato' Rafiq, or Dato' Sri Kamal, Prof. Megat to answer. The first question is, would you say engineers in Malaysia are becoming saturated, or are there still opportunities for the youth to penetrate the market? Anyone would like to answer that?
Probably I might want to answer that.
Okay, sure, please.
Yeah, if you look at the number of graduates coming in, we are producing over 20,000 roughly, whether they are engineers or engineering technologists, let alone the engineering technicians, right? But if all of us actually come out and expect that we are going to work for somebody, for a company, right, then it is limited. But if you think about you are going to create jobs, right, then that's a different thing altogether. And this is something that the policymakers will have to look at it seriously, as well as to provide the necessary environment for the growth. Because if you look at our engineering, let's say, landscape, we may have over 6,000 engineering companies, or even more in some cases. But if you think seriously about it, most of them, they are not that many major ones, and they cannot really absorb all of us who actually graduate from the universities. So that creation of new areas, being entrepreneurs, that means providing avenues to actually expand. So it becomes the responsibility of the government, the universities, to look at it seriously in providing the right courses or programs. And then, of course, the private sector has to play a role in terms of financing these. So it is not a simple solution, one would say, but for a country to progress, you need engineers. And the greater the number of engineers, the better it is, as what we have seen, for example, in Germany. You're talking about a ratio of 1:80, or that means to say, for 80% in the country, you have 1 engineer. Doesn't mean that they are going to work directly in the engineering sectors, but they will contribute towards the progression of the country in other avenues as well. We know a lot that engineers are also working in the banking sectors, in auditing sectors, and many others, right? By virtue of their ability to analyze things much better, in a sense. Maybe others can contribute.
And anyone else like to contribute for this question?
That Engineer Zairul.
Yes.
Oh, just very briefly, I think continuing from what mentioned by Prof. Magad, I think we look at statistic, we are still far away from advanced countries in terms of ratio of engineers to population. I can't recall exactly the figure that we are now, but I think we are behind Germany, we have France, and even Singapore, I think. So we need a lot more engineers. I was mentioning earlier on in my sharing session, we engineers, we shape the world, certainly we shape the nation. So as we move forward to become industrialized country and advanced country, we need a lot more engineers. And so I truly hope that more students will come forward. We see a decline in overall students taking engineering, whether in public universities or private universities. This is a cause for concern to all of us. I think we have a lot of work to do to get more students to take up engineering and contribute to advancements of the country. And this is our collective effort. Engineering is challenging, but it's very meaningful profession. You enjoy, certainly will enjoy. It is never down. You can feel the satisfaction if you build the facilities for the people, for the society at large. So please share the information. Please encourage more students to take up engineering, and we become very important engineering fraternity for the country, inshallah. Thank you.
Thank you, Dr. Sri. One question from one of the participants. How much salary for a fresh graduate will consider as a success? Maybe to Dr. Rahim?
I think in terms of salary, is it? The question is about salary.
Yeah, how much salary for a fresh graduate will consider as a success?
Yeah, the issue is that there's a study was done by BM about I guess 2 years ago. It's gone to the cabinet about apa jurutera miskin. So I guess the point I'm going to make is that depends on where you are actually applying, where you intend to work. Yeah, I think this is again, if you are working in the corporate sector in GLCs, the likes of Petronas, perhaps they pay quite well. It's about, I think now it's about 4K a month. But if you go into the private sector, which is very more specialized, which is there's the service providers, the likes of international service providers like Schlumberger and so on and so forth, they pay much higher than that. Yeah, but of course, the issue is that the majority will get into the so-called SMEs, these small, medium industries and so on and so forth. And that's where the issue becomes. Yeah, the issue becomes that you are competing then with other more experienced technologists, yeah, more experienced, perhaps not as qualified as you, but they have more experiences. So you are competing in that arena. And that can range between even 2.5 to even 3.5 per month, yeah, as far as pay is concerned. So my take on this is that you get whatever you can get, the best out of it, get into that work particularly, and be able somehow or other to contribute and add value. Because if you add value, then subsequently your employer will somehow see that, and you can actually, I guess, not demand, but perhaps request for a review of the pay, maybe 6 months, a year after that. Yeah, I've got some people who has got that experience before, and they see the value, they up it up because you are contributing to the company that you're working for. So my take on this is that get whatever you can get, yeah, the best at that point in time, and then make sure that you contribute and add value to the company, because the company will see that, and hopefully it will actually start to move your pay further up. And as I said again, make sure that you consolidate your skills, your fundamentals must be very strong, and do other things which perhaps I mentioned about AI, yeah, maybe automation, digitalization, and so on, because these are the companies that maybe do not have that capability to go to the next level, and this is where engineers plays a very, very important part. Yeah.
Thank you so much, Dr. Rahim. So this is the last question for each of the panel. If you can share what are some of the best resources or event that you've gone through that help you progress in your career and your last word to the student, for the engineering student. So I start with Dr. Rahim first.
The question again, Zarul, the first one?
What is the best resources or events or any program that you've gone through previously to help your progressing your career, and your last word to the student?
I guess the events is that in terms of career progression, you don't stay in one particular role for too long. Maybe 3 years in one role, not companies, in role. Maybe you become a graduate engineer, subsequently you become a project engineer, subsequently you become a senior project engineer. So you move from role to role. And then if you're in engineering, you may want to actually go into operations to broaden you up so that your fundamental is strong, but you broaden your T, yeah, so that you can contribute to the company in other areas as well. Because the experience you have is very, very beneficial to the company that you work. So you move on and you take on role which is uncomfortable to you. At first, it's uncomfortable, but as you gain traction, you become much more, I guess, competent in those particular areas, and you take on more responsibility in that sense. Yeah, but as I said, make sure your fundamentals are strong. Make sure your lifelong learning is always there, and make sure you have impact in terms of what you do. That's my take. Thank you.
Thank you so much, Dr. Rahim. Dr. Rafiq?
Sorry, what was the
What's the best resources or event or new programs that you've gone through previously that help you progressing your career, and your last word to the participants?
Right. Last word to the participant. I believe that all of you are engineering students. So I would say that congratulations to all of you for choosing engineering as your degree of choice. Because as I mentioned in my presentation, Malaysia needs a lot of engineers. Engineers are the one who develop any countries. If you look around the world, if you see any countries that are underdeveloped, they need engineers. They need engineers. To go for developing countries, and developing countries need engineers to become a developed countries. And if we are already a developed countries, we need engineers to go beyond, to go far and beyond. So we need all of you. So I would say congratulations to all of you for choosing engineering as your degree of choice. And I hope to see all of you once you graduate, and can have a further discussion on where we can join together and bring our nation forward. Thank you, Engineer Zairo.
Thank you, Dr. Rafiq. Datuk Sri?
Thank you for the chance given to speak this morning. I had the opportunity to work in various sectors or platforms. I was in working as a lecturer and eventually a professor in civil engineering, and I had the opportunity to work as a consulting engineer. So those actually the combined experience over the last almost 40 years was very important to me. I started as a lecturer, then I left university and worked in consulting firm, then went back to lecturing. So those experience, helped me to guide students at university. So to me, I agree with what has been said by Dr. Rahim. In whatever we do, you have to be passionate about it. You have to give the best and try to contribute as much as possible. I would always say, so sometimes, you people is oh God, it's Monday because weekends you have to start working. So oh God, it's Monday. I think we as engineers will say, yeah, it's Monday for me to go back to work and to contribute, to our company, to our society, and so on. In anything that we do, we have to do with with passion. We have to be committed. We have to try our best. It's always never stop learning. So you have to have the appetite to learn throughout your career, and you'll improve yourself. I was given the task to speak about ethics and professionalism. I think in anything that we do, that should underpin, our career advancement. Ethics and professionalism should be the underpin engineering profession. So if that's the way that I think for us to move forward, to ensure the integrity and the sustainability of our profession. A lot of people say, you tend to, we will be exposed to a lot of things as we work. But if you hold on truly to our principle, hold on to ethics and professionalism, we will not go wrong, inshallah. So thank you for the opportunity given, and hope all the best to students. I trust you'll do well in your studies and become graduate engineers, then eventually become engineering technicians or engineering technologists or professional engineers, inshallah, and contribute well to our beloved Malaysia. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Thank you so much, Datuk Sri. And last but not least, Pramagat?
Yeah, I would say university experience should not be left out. It's very important. Get involved yourself at the university level, whether at the departmental or at the university at large. Be involved and take all those possible opportunities for you to get involved. Take it. But at the same time, you cannot avoid, sometimes an opportunity knocks, right? If you think that you may not be suitable because you are not ready, you have to somehow change that attitude, right? You should take up the challenge. So apart from getting that experience at university, take up challenges. But of course, you don't over-promise things, right? You have to work hard, but of course, work smart and be around with mentors who may be able to help you with all the wisdom. So don't work in silos. You have to have a teamwork, because you know that teamwork will progress further and success will definitely be at the end of it. You cannot just work alone. So it is important that you, at the end of the day, take charge of whatever is being given to you, but be humble and work your way through. And opportunities will open up as we go along. So with that, thank you very much for giving me the opportunity to talk to all of you.
Thank you so much, Pramagat. Ladies and gentlemen, across the 4 modules, you are introduced to a holistic view of the engineering technologist profession. Module 1 highlights the diversity of engineering careers and the importance of continuous learning. Module 2 explains how engineering practice is governed in Malaysia and why professional recognition matters. And Module 3 reinforces the role of ethics, integrity, and responsibility in every engineering decision. And Module 4 broadens perspective by showing how engineering solutions influence society, the environment, and the world at large. Together, these 4 modules offer a complete understanding of what it means to be an engineer, balancing technical skill with professional responsibility, ethical conduct, and global awareness. We hope this helps you appreciate the purpose of each module and gain maximum benefit from the ERS lecture series. Thank you once again to all the speakers, Datuk Rahim, Datuk Rafiq, Datuk Sri Kamat, and also Promagat. And thanks again to all participants for attending this webinar. Please scan the QR code showing on the screen now to download your e-certificates. On behalf of the Board of Engineers Malaysia, I would like to wish all of you the very best in your studies. And once you have completed your program, please do not forget to register with BM. We also wish you the very best in contributing to the engineering profession and to the development of our country. Thanks once again. Assalamualaikum warahmatullahi wabarakatuh. Thank you.
Thank you.
Salam.
Salam.
Oh, thank you, Datuk.
Thank you. Okay.
Well spoken. So next week, yeah, one more session.
Itu